All right, let's dive into the world of LLMs. You know, those large language models.
Yeah, fascinating stuff.
They can write poems and even answer those trivia questions we all love.
Right, but today we're not focusing on just making them bigger.
We're talking about making them smarter.
Exactly, like better thinkers.
Yes, it's all about how these models actually reason and solve problems, not just generating more text.
That's the key, making them more efficient thinkers.
So you shared this research paper with us, the one titled Optimizing Test Time Compute via Meta-Reinforcement Fine-Tuning.
It's a mouthful, right?
It is, but it's like a training manual for LLMs to become, well, like smarter and more efficient.
Think of it like trying to solve a really tough puzzle.
Okay. What, yeah.
Just having more time to stare at it doesn't mean you'll find the solution.
Give me a strategy, right.
A good approach, exactly.
So it's not just about giving these LLMs more data or more time.
It's about teaching them how to use that time and data effectively.
I see. So even with all the data in the world,
it won't matter if they don't know what to do with it.
Yeah, that's interesting.
And the paper highlights this problem, how even state-of-the-art reasoning LLMs.
The really advanced ones.
Yeah, like the DeepSeek R1 model they studied.
Correct.
Sometimes they don't actually get better when they're given more processing power.
They just hit a wall.
It's like their performance plateaus. Or sometimes, and this is wild, it even gets worse.
That is surprising.
More power, less results.
It's like they get lost in all the information, right?
Drowning in data.
Overwhelmed.
Yeah, not sure what to do with it all.
So how do we fix that?
Well, that's where this concept of cumulative regret comes in.
Regret, like the LLM is having second thoughts.
Well, not exactly. Imagine the LLM has a limited budget, for thinking.
Okay, a thinking budget.
Yeah, we can call them thinking tokens. Each token is like a step in the thinking process.
Okay, each step costs a token.
Right, and if it spends those tokens poorly...
It's like wasting money.
Exactly, that's the regret. It's like, ugh, I wish I had thought about that instead.
I see, so every decision matters.
Every token counts.
So how do we prevent the LLM from having this regret?
Well, the researchers have this solution they call MRT. It stands for Meta-Reinforcement Fine-Tuning.
MRT.
It's like a coach for the LLM.
I like that, a coach.
Training it to be more strategic, with its thinking.
Okay, so instead of just letting it loose...
We're giving it some guidance.
Right, so tell me, how does this coaching actually work? Does the MRT, give pep talks?
Not exactly pep talks, but more like it gives feedback, targeted feedback.
Oh, interesting.
So instead of just rewarding the LLM for getting the right answer at the end, MRT gives feedback at each step of the thinking process.
Wow, that's a lot of feedback.
It is, but it's important, so the LLM can learn.
Learn from its mistakes.
Yeah, and refine its strategy.
So it's getting constant feedback to improve its game.
Precisely. Think of it as continuous improvement.
Okay, and they tested this MRT approach, right? What were the results?
Well, the results were actually pretty impressive. When they applied MRT, it consistently did better than the standard training methods.
Yeah.
Yeah, across different math reasoning benchmarks, which is what they were focusing on.
Math problems.
Yeah, and some of the models, the MRT-trained models, they even achieved state-of-the-art results.
Really? That's amazing.
For their size, meaning they did better than other LLMs with similar resources.
So it's not just about being the biggest.
It's about being smart and efficient.
Yeah. Using your resources wisely.
Exactly. And that brings us to another key finding. The MRT models were much more efficient in their reasoning. They solved the problems using significantly fewer tokens.
Fewer tokens, so less regret.
And that means they were faster and cheaper to run.
That's a win-win, right?
Absolutely. Efficient and accurate. It's what we want.
So they're learning to think smarter, not harder.
Precisely. And here's another fascinating thing. The MRT models even performed well on problems they hadn't seen before.
Oh, so they can generalize their skills.
Yeah, suggesting that this training method, it helps LLMs to apply their reasoning to new situations.
So it's not just about memorizing patterns. It's about actually understanding.
Understanding how to approach problems, like critical thinking.
That's really interesting.
It is, and it brings us to another aspect of the research, the length of the output, how much text the LLM generates.
Okay, I'm listening. So longer outputs mean more complex reasoning, right?
Yeah.
More text, more thoughts, more solutions.
That's what you might think, but it's not always that simple.
Oh.
Simply forcing the LLM to produce more output, it doesn't guarantee better reasoning. Sometimes it can even backfire.
Really? That's counterintuitive. I always thought more is better.
Well, not in this case. Imagine writing an essay, just adding more and more sentences.
Without a purpose.
Yeah, it won't necessarily make it a better
I'll
essay.
get confusing.
And the same thing can happen with LLMs. They can just keep churning out text without actually making any progress towards the solution.
I see. So it's not just about how much they think. It's about how well they think.
You got it.
So it needs to be concise and focused.
Exactly. Quality over quantity.
And did they find anything about how the length of these outputs evolves during training?
They did. It's actually a complex process. It doesn't just steadily increase the length. It goes up and down.
Up and down.
It's like the LLM is searching for the right rhythm for its thinking.
Interesting. Trying different things out.
Experimenting. And that raises some questions about how we approach training. What if instead of giving them a huge thinking budget right away,
A huge budget from the start.
we gradually increase it as the LLM progresses through training?
Like starting small and then giving them more as they learn.
Exactly. Like you said, starting small and gradually increasing it.
It's like training for a marathon. You wouldn't start with a full marathon right away.
Precisely. You build up to it.
So this gradual increase, it's like scaffolding the learning process.
Yeah. And they found that this actually led to more efficient learning.
More efficient.
The LLMs learned to use their thinking time more strategically, not just waste it.
Wow. So much to unpack here. This MRT approach sounds like a game changer for how we train these LLMs.
It's definitely a promising direction, and we're just scratching the surface.
This is already blowing my mind, but I'm eager to hear more. So for now, let's take a quick break, and we'll be back to delve even deeper into this fascinating world of MRT and how to make LLMs think smarter. So we're back, and we're still talking about this MRT, meta-reinforcement fine-tuning.
Right. This technique that's all about, making those large language models even smarter.
Making them think better, like
A chess grandmaster.
yeah, exactly, planning those moves carefully.
Because, just having more pieces on the board doesn't automatically make you a better player.
Right. It's not about the quantity.
It's about strategy, about how you use what you've got.
And this research, it's really digging into that, right?
Yeah.
How the structure of the LLM's thought process.
Yeah, how the thought process is just as important as the size.
It's like building a house. It's not just about having a pile of bricks
It's about how you arrange them.
to make something strong and functional.
And that's what MRT aims to do,
Give it some structure.
encouraging the LLMs to break down their thinking, instead of just
rambling on.
long streams of text
More organized.
into these distinct episodes.
Oh, right. You mentioned those episodes before. Can you remind me again what an episode is in this context?
Sure. It's like, think of it as a unit of reasoning, like a mini problem-solving session.
Okay, a mini session.
It could be, trying out a certain approach, testing a hypothesis.
Or even going back and correcting mistakes.
Exactly, reflecting on those previous steps.
I see. So it's like breaking down a big problem into smaller chunks
More manageable pieces.
so the LLM can focus better.
And by doing so, by breaking it down like this,
It allows for more feedback.
more effective feedback and rewards.
Right, like that coaching analogy we were talking about earlier.
With MRT, the coach can give feedback not just at the end, but on each episode,
Ah, so it's getting feedback along the way, not just on the final result.
which seems to be key, for training these LLMs.
Training them to be more strategic,
And as we saw earlier, more efficient.
using fewer tokens, less of that regret.
Exactly. So, but here's where things get really interesting.
Okay, I'm intrigued.
They also looked into, how the length of the LLM's output.
How much text it generates?
Yeah, how that relates to its reasoning ability. And what they found was surprising.
Surprising. I always thought, longer output meant more complex reasoning. More words equals more thoughts.
Right. It's a common assumption, but it turns out it's not always the case. Just forcing the LLM to produce more.
Just making it talk more.
It doesn't guarantee better reasoning. Sometimes it's even counterproductive.
Wow, really? That's kind of counterintuitive. More isn't always better then.
Not always. Think about it. Like, imagine you're writing an essay and you just keep adding sentences, without a clear purpose.
Just rambling on and on.
It becomes confusing. You might even lose your point in all those extra words.
Yeah, less can be more sometimes.
And that same thing can happen with LLMs. They can just churn out text without making any real progress.
Wasting those precious tokens.
Exactly. So it's not just about how much the LLM thinks, it's about how well it thinks.
It needs to be concise and focused.
Quality over quantity. That's the key takeaway here.
So did they find anything about how the length of these outputs, how it changes during training?
They did, and it's fascinating. It doesn't just steadily increase. It
Right.
goes up and down.
Like a roller coaster.
It's like the LLM is trying to find the right rhythm for its thinking.
Trying different lengths out, experimenting.
That's a great way to put it. And this raises questions about how we train them,
How we train them.
What if instead of giving them a huge thinking budget right from the start,
Right.
we gradually increase it as they go through training?
Like a gradual increase in difficulty.
Exactly.
Like starting with simpler problems.
And then moving on to the more complex ones.
As they learn more.
Precisely. And guess what?
They found that it works better.
Yeah, this gradual increase, they call it curriculum learning.
Curriculum learning, like in school.
And it led to more efficient, more effective learning.
The LLMs learn to use their time more strategically. That's fascinating.
And this actually aligns with other research on LLMs, for example, when training them for self-correction, catching and fixing their own mistakes.
Right.
A similar approach has been shown to be more effective.
So it's not just about throwing data at the problem. It's about being more strategic in how we train these LLMs.
Understanding how they learn best.
Which brings us to another interesting part of this research.
The role of the meta-prover.
The meta-prover, right? We talked about that a little bit.
It's the component that's responsible for, evaluating the LLM's progress at each step.
Like the coach giving feedback. But how do you even design something like that? It must be pretty complex.
That's one of the big challenges. There are different approaches using a separate LLM as the meta-prover.
Separate LLM.
Yeah, or even having the LLM evaluate its own progress, but each approach has its own challenges and trade-offs.
Yeah, so designing this meta-prover, like its own AI coach, that's a whole other challenge in itself.
It is. It's like trying to create a coach that can guide a team of really brilliant but sometimes unpredictable players.
Right, because they can come up with some pretty wild ideas.
Exactly, and you need that balance,
Between being structured
and giving them the freedom to explore.
So it's not just about the meta-prover, though, right?
Yeah.
We were saying how the LLMs themselves.
Yeah, the LLMs need to have certain qualities.
Certain traits for this MRT training to be effective.
Exactly. Not all LLMs are created equal. Some might be better at...
Some are better at math, some are better at writing, like us humans.
Yeah, it's about finding the right LLM for the right task.
The right tool for the job.
And one thing they found that's crucial is the LLM's ability to explore different strategies.
So it can't be too rigid.
It needs to be flexible, think outside the box.
Not just following a set of rules blindly.
Exactly. Try new things, experiment.
So a bit of a creative thinker.
You got it. And if the base LLM isn't adaptable,
the MRT might not work as well.
It's like, trying to teach advanced calculus to someone who's still struggling with algebra.
Right. You need that foundation.
You need a solid base to build on.
This is all so fascinating. It's like we're really understanding how these LLMs think.
And there's still so much we don't know. It's an evolving field.
Speaking of challenges, we talked about, the cost of this MRT training, the computational cost.
Right. It can be resource intensive.
Especially with these huge LLMs, the ones with billions of parameters.
Yeah, because even though MRT leads to more efficient LLMs in the long run.
Right. Fewer tokens when they're actually solving problems.
The training itself can require a lot of power.
A lot of computing power. But, it's like any investment. It might be expensive up front, but it pays off later.
That's a good way to put it. And researchers are trying to find ways to make it more efficient.
To make the training more accessible.
Yeah, so it's not just limited to, huge research labs with tons of resources.
Right, so more people can benefit from it.
Democratizing access to this powerful tool.
Because who knows what we could do with these smarter LLMs? The possibilities seem endless.
We could see breakthroughs in so many fields. Science, medicine, art, you name it.
LLMs writing novels, composing symphonies, maybe even designing new medicines.
It's an exciting time to be following this field, that's for sure.
It definitely is. So much potential. Well, I think we've reached the end of our deep dive into this world of MRT.
It's been a fascinating journey.
It really has, and I hope our listeners enjoyed it as much as we did.
Thanks for joining us.
And remember, when it comes to these LLMs, it's not just about size.
It's about how you train them to think.
Think smarter, not harder. Thanks for listening.